everyone. I'm Samah Kansab. I'm a PhD student at ETS, Ecole supérieure de technologie. I will be presenting my work on leveraging machine learning data to analyze the DevOps practices. These insights are coming from a networking software solution company. So my presentation outline is the context and problem statement, related work, research objectives, methodology, result, and implications. So to start, let me introduce you on what we are working in general. So perhaps somebody of you are already using the DevOps pipelines. So DevOps pipelines are the combination of the development and operation to create a parallelization and automation system that can help the production of the software product. So if we define it, in other words, it's a set of steps that are automated from coding to deploying and furnishing the service of the software at the end, and it helps to automate all the tests, the release, deployment, monitoring, etc. And one of the advantages of this system is that it ensures the collaboration and the productivity, and while it is automated, it can help to save more time and improve the software quality and delivery because it reduces the manual involvement in the process. So one of the steps of these pipelines is the code review. What is the code review? Is the examination of the code written by a team member by another one. For example, let's say you are a team member A, you are writing a code, you are working on a feature. So once you finish it and before you integrate it in the main, you need to ask someone else in your team to revise this code for you and check that everything is okay. So this process, we call it code review, and perhaps you are guys working already with GitHub, GitLab, or any other tool like Git to share your code or to post your changes. So the advantages that help to check performance, verify the completeness, improve the code, and before we integrate it to the main code, we avoid a lot of problems coming from like one developer, and that can block the process. So one of the processes of this code review is the merge request. So the merge request is a mechanism, let's say, of GitLab that help to incorporate changes from a source branch, like the branch on which you are working, and posting your code to a target branch, which is a final one, or the main one that is used for production. So there is contributors in the code review. The first one, let's say the author. The author is the one who is writing the code. The second one is the reviewer, is the team member who is supposed to review and make comments on the code. And there is other parts of this process, which we call commenters. The commenters are people from your team, let's say your manager, the product owner, or whoever member who can put comments on your code saying that, for example, your documentation is not clear. Can you please improve this feature? Can you please try this? They are just external people who want to collaborate on such changes. So the process starts when we open a merge request. So we go to GitLab, then you open a merge request. Then you ask for review, so the reviewers will receive the review. Then they will ask you for updates, for discussions, for answering questions. Then you, from your own, and you may have committers. Who are committers? Are the team members who are working on the same feature with you. You can update the code, discuss with the reviewers, or see any further details. There is commenters, as I said earlier, who are external people that want to collaborate on your changes. And we have at the end a role which is called an integrator. Who is the integrator? The integrator can be an author, can be committer or a reviewer, but the integrator is the one who takes the decision at the end. So he say, your merge request can be accepted and we will use your code in the final product, or the merge request will be refused and you need to see what is the problem with your feature and rework it again. So the code review advantages is improve the code quality, enhance the skill of the team members. So if you have, for example, a beginner with you and he don't know how to code well, so the code review is the good opportunity to learn and to get comments from your team members to improve your skills. Then also develop some consistent practices in the team and also share knowledge with others. So if you are a senior developer in your team and you want to share your knowledge with others, this is the opportunity. So let's see now what the literature is doing till now on the code review. So we conducted a systematic literature review on scientific databases to see what people are doing on code review, and also how do they use machine learning pipelines for software engineering, or how they are using machine learning in general to improve the code review process. So here are the databases that we checked, and we explored more than 100 papers to see what people are doing in the literature. So starting by the automation of the code review. So as you noticed, perhaps the code review is a manual process. So it always require manual or human involvement to validate or not the changes. And as I said in the first slide, the principle of the DevOps pipeline is to automate the process. So while we have the manual involvement, for us is problematic because we don't want the manual involvement. We want to reduce the manual errors, the human errors. So people are hardly working on automating the code review. So they are, for example, working on generating the tests of the code automatically before going to the manual text, generates the code using the deep learning. So when the code is generated by the artificial intelligence, we assume that it will have less syntax error and so on, and also develop some machine learning models or some now LLMs to identify the errors, to correct the error. And if you see, for example, now the biggest environments of coding like IntelliJ and so on, for those who are using them, or PyCharm for people using Python, you see the autocomplete in the premium version. So every automation is necessary to avoid the manual involvement. And also they are working on the code completion for bug avoidance. So when your code is completed, we can check for bugs. And people are also integrating this solution in the industry, like Samsung, Google, Microsoft, and the very big other companies that are also integrating these automated system to reduce the manual involvement of people. Second, people are working on the explaining of the code review process. Okay, so we have the code review, people are collaborating. Now, what we want to explore is what people are doing during the review process and why the review process, for example, is taking such a time. What are they doing in this time? So we studied like the code review completion time, how much time it can take to complete a merge request. So we open a merge request, we ask for a review, how much I need to wait to get the first comment or to get my merge request accepted, etc. Like all these factors that are related to time. Second, the factors that influence the review participation. So, for example, we study what are the characteristics of the merge request that attract reviewers, because we notice that, for example, people can ask for merge for open a merge request, they ask for a review, but there is no interaction from their teammates. And we observed that there is some factors like the experience of the developer. So people are more interested to collaborate with a senior developer in the team compared to a newbie. So all those factors have been explained and studied, and there is also industrial perspective in this side, like in Microsoft or Google, that are also adopting these solutions that explain the code review process. So now, moving to our research objective. So when we conducted the systematic literature review, we observed that people, in fact, are using the data coming from code review, but the problem is that they are using this to analyze the code review process itself. So they are interested in what's happened in the code review process. While from our side, we see the code review process data different and very rich with deeper information that we can use to analyze all the DevOps workflow and not only the code review. So our objective in this work is to use the same data used by people, but to retrieve different informations. If they are retrieving just conclusions and information on the code review and what is happening in the code review, we want to show them that the code review data, can be used for other purposes, helping to improve the DevOps pipelines in general. So we include in this study the analysis of the environment changes like COVID-19. We want to show to people how we can analyze the changes left by the COVID-19 through analyzing the data provided by the code review. Second, analyze the process changes, for example, migration to OpenShift when the industry decide to change the technology. For example, let's make it simpler. You are in technology, in an industry, working with Java, and you decide to merge to Python. So what is the impact of this migration? So it's need to make perhaps training for developer, make them familiar with the new technology, etc. Second, the branch usage. So in the GitLab or GitHub, for people who are familiar, we have branches that you create to post your own code. So how we manage these branches can also provide interesting information. And last but not least, is the factors that influence the code review efficiency in industrial setting. And here we will use the same methodologies used in the literature for our industrial partner. So let's move to the methodology. So to be brief, we collected data from 2019 to 2023 via GitLab API on different projects that cover 5 teams: management plane, control plane, data plane, platform plane, and FPGA. And we collected more than 24 metrics on the merge request, like time to get the first comments on the merge request, number of commits, time to get the review, etc. Then we used mixed method analysis like statistics, machine learning, and we analyzed different aspects for COVID-19, OpenShift, and branches, and finally the machine learning aspect. So let's move to the results. So our first research question is, what is the impact of the pandemic COVID-19? And let me put you in a context, like the company that we are analyzing, we're working on seat, so every day from 8 to 5. Then at the arrival of the COVID-19, people needed to work from home. So here people are changing the environment. Developers were working always on site. Then the new habit is to work home. So the circumstances are changing. People are at home. They have perhaps kids. They have, I don't know, uh, they are living with people. So all the circumstances and the environments is changing here. So we aim through the code review to analyze the impact of COVID on different metrics, which are, first of all, productivity. So we assess productivity by seeing how much merge request was creating and closing per week before and after COVID. So we analyzed 11 weeks before COVID and after the COVID. Then also the effort. The effort is measured in the literature by looking at what we call the lead time, or the time to complete the code review. So we have analyzed how much the merge requests take in average before and after COVID to get accepted or rejected, and also the temporal autonomy. So we see when these merge requests are created, because, as I said, before COVID, people were working at SIT, so the merge requests are created from 8 to 5 p.m. And what we want to see is if the COVID left an impact on the long term. So if people had adopted this habit of working out of the regular working hours. So our findings show that the productivity overall during the migration from working on site to the home was almost stable. We see that the number of merge requests created and closed per week remained almost stable before and after the shift to the remote work, and this go with an increased review time. So we see that the review time goes from 3 days to 10 days. But this increase in review time, or let's say effort, it can explain the stable productivity. So people are doubling their effort when they are working from home to keep the same productivity, because, as I said, like, working from home at the beginning was very difficult for people who are like almost familiar with working on site in the industry. Then looking at the temporal flexibility, we see a greater temporal flexibility. We see that people just got the habit of working out of the regular working hour, and even after the pandemic, people are starting working before 8 a.m. and after 5 a.m. p.m. Sorry, so they are adapting the new, let's say, uh, the new life mode. Like, they are more familiar with working after 5 p.m. They are more flexible on the working habits. Now, looking at the process changes, which is in our case the migration to OpenShift. So at some points in our industrial partner, they wanted to migrate to use a technology called OpenShift. So we analyzed the efforts also by looking at the time, then the change magnitude to see if people, so the change magnitude is the number of lines that is added in the code and the number of line which is deleted. So here we want to see if people are just adding new functionalities by, so the number of added line is more than the deleted one, or they are equal, so people are refactoring the existing code, or just deletion, so people are cleaning their code. So our findings show that in the beginning, we observe a slowdown. So we see that people are very slow to answer the merge requests that are related to OpenShift, which makes sense because people are not familiar with the new technology. So they are taking more time to review and validate the proposed changes. And at the time, there wasn't like ChatGPT, and also so they needed to document, see at Google what the other one asking for a review is doing, and so on, so which make quite the task difficult. So we see that there is a slowdown at the beginning, but After that, we see a stabilization in the effort looking at the time, so people are getting more familiar with the new technology. Then we also, in terms of merge request size, so the size of the feature of the code, we see that at the beginning people are just asking for to review a small merge request, so just few changes. Why? Because people are just in the beginning of the use of the new technology, so they are going step by step, like they are afraid to make large changes that can cause a lot of problem in the software at the end. So in the beginning, we see that people start by asking for small changes. Then with time, the changes gets larger. Also, we see a significant code rework. So if we analyze the nature of the changes that are doing during the code review, we see that people are replacing the existing code instead of adding. So they are just refactoring what exists to adapt it to the new technology. Then we see that overall there is an impact on the workflow, because we see that there is some delayed tasks on the other tasks that are not related to this migration, because all the focus on the is on the new migration to technology. So at this time we ignore a little bit the other functionalities or tasks and let them wait for a while to adapt the new technology. Let's move now to the third research question, is the branch management. So here we analyze also the efforts, change magnitude, and collaboration aspect to see how people are collaborating, and we analyze three types of branch. Let me explain these branches. So the first one is called main. The main branch is for daily development, and stable is just the branches that are used to release, like to the final product. So you see the version, for example, Facebook version 1.1.0. So this is on stable branch that is go to the public, then 1.2 another branch for the next version, and so on. And we have temporary branches which are used, like for example migration up to OpenShift, as I explained. So briefly, we find that the faster reviews are on stable branches and they are prioritized. So in the team, the engineers or the developers are more interested to resolve problems or review the stable branches because they are very important and they touch directly to the final product. So when we have a merge request on stable branch, we see that all people run to review and close this merge request or resolve the problem before seeing what happened in the main. Then also in terms of first feedback, we see that the comments on these branches are 2 to 3 times faster than the other branches with more intensive collaboration. So we see that there is more comments, more reviews, more interaction on these branches. Finally, we move to the fourth research question, which is bots compared with humans in code review. So we analyzed the comments received by the bots, the automated one, with the comments received by humans. We see that up to 70% of the first comments on the merge request are bot generated, but we see that people wait for the first human comment to close the merge request or to decide on what to do on the merge request. And also we analyzed what really impact the review duration using the machine learning models. So our machine learning models show that the time to first comment explain 94% of the review time variation. So if you have a merge request, if you get the first comment faster, so the merge request will be closed faster. So this is the most important let's say factor impacting the time to complete the merge request. There is other important predictors such as the number of commits. So more you have commits, so the larger are your changes, so which can take longer to verify. Also, if the author is also a reviewer, because sometimes we see that we have self-review. So if you are the review of yourself, sure, you will close the merge request in few seconds because you don't need an external validation. We have also description length. So more you detail the description of your merge request, more the changes are clear. And at the end, we can say that bots can help, but a human are the people who drive the completion of the merge request. So finally, let's talk about the implications. So in general, we conclude that the merge requests are rich of data for analyzing or tracking developer efforts and team dynamics, observing responses, for this disruption like the pandemic, technical shift, and understanding release priorities via branch analysis. So the take-home lessons that we want to share with practitioners is that the merge requests can be used for different purposes and not only analyzing the code review itself. It can help you to monitor developer effort, collaboration, prioritize the critical review like stable branches, and you can also use machine learning to predict all this and to explain, or now LLMs or deep learning to explain the delays, trigger alerts, etc. And that can help at the end to balance the automation with the manual intervention. If we talk about the limitation of the study, like our study was conducted on one company. So this company was, for example, shifting during the COVID-19. It have the OpenShift, and people who are working have different culture and different policies. So once we change the company, we will see other observation, we'll see other culture, other policies. So the limitation is on the generalization of our study. So our study is, the findings of our study can be not easily generalizable, on other companies. So we invite people to run themselves our methodology to explain, or to, let's say, to investigate data provided by the code review to see what it can give on their own cases. So thank you very much.